Hello everyone, welcome to another video. Today I want to show you how to use the Azure Key Vault Secrets Provider extension to synchronize the secrets from your Key Vault into your Kubernetes cluster. So the plan for today is, first I'm going to tell you what the Azure Key Vault for Secrets CSI Provider extension is. The name is quite a handful, but you will see that using the extension is quite easy. Then we're going to create an AKS cluster with Entra Workload ID. Entra Workload ID gives our applications managed identities, and then we're going to use this managed identity to access the Key Vault. If you don't know what Entra Workload ID is, I published a video last week where I go into all the details and a step-by-step setup for the cluster. So I will link the video and you can take a look if you're interested. After we've set up the cluster, we're going to install the Key Vault extension. Then we're going to configure the synchronization between the Key Vault and the cluster. And at the end, we're going to test if we synchronized our secrets. And I'm also going to show you some additional features like auto-rotating the secrets and automatically updating the secrets. So first up, let's take a look at the Azure Key Vault Provider for Secret Store CSI driver extension. What this extension does is it allows you to mount secrets, keys, and certificates from your Azure Key Vault to your pod that's running in Kubernetes. The extension also allows you to auto-rotate your secrets. This means if you update the secret in the Key Vault, it will automatically also update in the Kubernetes cluster and you don't have to do anything. Next up, we can also sync with our Kubernetes secrets. I'm going to show you this later in the demo, but what we can do is we can tell the extension what secrets we want to take from the Key Vault and then create secrets in the Kubernetes cluster. Additionally, we can also mount multiple objects. This means we can mount secrets and keys and certificates into a single volume. And this allows our application to consume all these different kinds of objects from a single point. This makes the management and the usage very easy. And the last advantage is the separation of concerns. As a software developer, I don't really care where the secrets are coming from, if they're stored securely or not. Hopefully I care if they're stored securely, but I only want to consume them. And with this extension, the developer can focus on just using the application and using the secrets in a way they want, for example, as environment variables. And then a cluster administrator can make sure that the secrets are synced into the cluster. And the developer doesn't have to update the application. We're also going to see this in the demo in a minute. First up, I want to take a quick look how all of this works. So when we start a new pod or a new application, then the Kubernetes API on the master node communicates with the kubelet that's running on the worker nodes and then instructs the kubelet to start the pod. And the kubelet configures the secret store CSI driver, and this secret store CSI driver has the secret store CSI provider. And this is where our extension comes into play. Our extension changes this configuration, and when the kubelet configures or starts the secret store CSI provider, the provider downloads the secrets from the Key Vault and then mounts it to the pod. And this means we don't have to change anything in our application. And as an administrator, you just have to install the extension and the extension will take care of the rest. It might sound complicated when you have never used it, and therefore let's jump into the terminal, create a new cluster, configure the extension, and then you will see how easy it is to use and configure this extension. Before we get started, let's configure a couple variables. First, we have the name for the resource group, the name for our Kubernetes cluster, and the location that's closest to where I am. Then we're going to configure the namespace, which we're going to use for our application. Then we provide a name for a service account. This service account is going to be used for the workload identity to authenticate in the Key Vault. Then also we're using an user-assigned identity and a federated identity. All of this is necessary to set up the identity with workload ID. Again, if you don't know what this is, or if you want to know all the details, I will link the video to last week and you will see all the details and a step-by-step instruction there. And lastly, we are configuring the name of our Key Vault. Then a secret we are going to add to the Key Vault to test our application. And we're also going to get the subscription ID and the tenant ID. And with this in place, we can start creating our resources. First, we're going to create a resource group. And this resource group will contain all the resources we are creating today. Next, we're going to create a Key Vault. And what's important is that the name of the Key Vault is unique worldwide and that we enable the RBAC authorization. This RBAC authorization allows our application to access the Key Vault. Next, I'm going to assign myself the Key Vault administrator role. Otherwise, I don't have access to the Key Vault, even though I'm the owner of it. So I just assign the Key Vault administrator role to my email address, and the scope is of the Key Vault. And as you can see, if you follow this demo, you only have to fill out the subscriptions and it will work. And obviously your email address. Then this takes a couple seconds to propagate. And now we're going to add a secret. So we're going to provide the name of the Key Vault, the name of the secret, and the value is going to be, this is a secret. And if you get an error message here, then you have to wait a couple seconds and then try again. This is usually because the assignment you did before hasn't been propagated yet. And that's everything we have to set up in the Key Vault. Next, we're going to create our Kubernetes cluster. So again, we provide the resource group name, the Key Vault name, the Kubernetes name, the location, and then the last two parameters are for the workload identity. So with the enable OIDC issuer, we have an OIDC issuer. This will allow us to get a token from Entra, and the same with enable workload identity. And again, if you're interested in the details, I will link the video to last week where you can see all the details. Creating the cluster takes around 10 minutes, and I'm going to stop the video and I will continue once the cluster is finished. With the cluster created, we can now configure our Entra workload ID. First, we're going to query the URL to the OIDC issuer. Then we're going to create a managed identity. This managed identity will be used to access the Key Vault. Then we also get the ID. And lastly, we assign this managed identity the Key Vault secrets user in the Key Vault. So we provide the role, as I said, the Key Vault secrets user. This role allows the managed identity to read the secrets and only the secrets. So if you follow this demo and you also want to read keys or certificates, then you have to provide a different role. I guess the role would be Key Vault certificate user to read the certificate. Then we provide the ID of the managed identity and then the scope to our Key Vault. This should only take a second. And now we can configure our Kubernetes cluster. So to do this, let's download the kubeconfig. What I always like for my demos is to create a new namespace, because at the end of the demo, I can just easily delete the namespace and everything is gone. Then I'm also going to set the context to the new namespace so I don't have to type the namespace all the time. Next, we are going to create a service account, and this service account will be added to our pod. And this service account has a link to the managed identity we just created. And therefore, our pod can use this managed identity to access the Key Vault. What's important here is this annotation, the Azure Workload Identity Client ID, and this is the ID of the managed identity. And with this, we have the connection. But again, I will link the video to last week where you see all the details. Let's save this, and then we're applying and creating the service account. And the last step is we have to create federated identity credentials. And this is what I said before, the link from our service account to our managed identity. If you're only interested in the Key Vault extension, you can just follow the commands. As always, there will be a link in the description to the GitHub where you see everything I'm using today. So you don't have to type anything. You can just copy it from there. Okay, now the cluster is set up and configured. And now we can actually configure or install the Key Vault Secrets Provider extension. And to do this, we use the AC AKS enable add-ons command. Then we provide the name of the add-on. That's the Azure Key Vault Secrets Provider. Then we provide the name of our Kubernetes cluster and the resource group. And installing the add-on will take around 5 minutes. So again, I'm stopping the video and we'll continue once the add-on is installed. The extension is installed, and to make sure that everything works as expected, we can get the pods in the kube system namespace, and there we'll see the extension. So if we scroll up a bit, we can see here the AKS Secrets Store CSI driver pods. Should be the 6. And we can see they've been created around 1.5 minutes ago. And they're also all running. So everything is good. And now we can configure our extension. So let's clean this up. And first, we're going to have to provide a secret provider class. So I'm going to paste it in the terminal, and then we go through it step by step. So the type of this Kubernetes object is secret provider class. The provider is Azure. Then we're using as a client ID the ID of our managed identity, and this allows us to access the Key Vault. Then obviously the Key Vault name, and then here in the object section we configure all the objects we want to synchronize from the Key Vault. In this case, we only have one object with the name of the name of the secret, and the type is secret. So even if you have 10 secrets in the Key Vault, we are only going to sync this one secret. And the same if you have certificates or keys, you also have to add them there with the name and with the type. And lastly, we have to provide the ID of our tenant. So we're going to save this in the variable, and then we're going to apply this variable. That's everything we have to do to configure the extension. To test the synchronization of the secrets, we're going to use an image called busybox, and then we mount the secrets into this pod. After the pod is running, we can inspect the mount. So let's paste the config here and then again go through it. So we have here a pod. So it's as simple as it could be to test. Then we provide our service account. This again is needed so our application can sign in into the Key Vault. Then we're using the image of busybox. And down here, we mount a volume. And we mount it in the path mount/secret store. And if you go down here to the volumes, here we configure that we are using the CSI driver of the secret store, and the secret provider class is the same name as the secret provider class we just created. So if you update anything in the secret provider class, especially the name, that's this one here, make sure to also update it in the pod configuration. Now let's save this, and then we're going to apply the configuration. Let's wait a couple seconds so the pod can be downloaded and started. And then let's check if the pod is running. And this looks good. If you have a problem with the configuration, then the pod usually doesn't start. But since the pod is running, everything should be fine. And to test this, we can use kubectl exec. Then we provide the name of the pod. And then we just use the ls command of the volume we configured before, where we want to sync our secrets. And if we check this, we see one value here, and that's the name of the Key Vault secret. And we can also take a look at the value of the secret. So again, we use kubectl exec, then the pod name, and this time we use cat, and we provide the path to the secret. And here we can see the exact same value we configured before. And this proves that we synchronized the secret from the Key Vault to our pod and attached it as a volume. So this proved it worked, but attaching secrets as a pod is not always feasible or the best solution, depending on the programming language you use. For example, in .NET, we like to use secrets or environment variables, and then we just read them. And it's not that simple to read from a volume. So now let's take a look how we can create secrets in Kubernetes from our Key Vault secrets. And to do this, we have to update our secret provider class. So let's copy it in the terminal, and on top, everything stayed the same. And the only change is down here. So now we have this secret object, and there we configure what secrets we want to create. So we provide a name for our Kubernetes secret, and then we provide the key and the object name. So in this case, they're both the same to keep it as simple as possible. And this object name here references this object name. So first you synchronize the secrets, and then you say what Kubernetes secret you want to create from the synchronized Key Vault secrets. Now let's apply the new secret provider class. And we can see the configuration has been changed. If we now check for secrets, or actually let's do this. So use the kubectl get secrets. There we can see that no secrets are there. This is because we don't have any automated or continuous synchronization configured. Therefore, secrets are only synced when our pods start. We're going to configure the synchronization in a couple minutes, but for now, let's delete our pod and then recreate it. To delete the pod, we're going to use kubectl delete pod and the name of our pod, that's busybox secret store. After the pod has been deleted, we're just going to recreate it. We don't have to change anything in the configuration because we just want our pod to start and to reload the secrets. And when the pod reloads the secrets, it will automatically create now Kubernetes secrets. Now we can recreate our pod. So again, we just use the kubectl apply with the busybox pod variable, and our pod has been created. This time it should start almost immediately. There we can see the pod is running. If we now check for secrets, so we use kubectl get secrets, we should see our one secret. There it is. It has a name we configured, and it should have the value of the Key Vault secret. So what we can do now is we can do a kubectl describe secret. Then we provide the name. So that's this name here. That's new secret. And there we can see the data is my secret. That's the name of our Key Vault secret. And if we now get the value of the secret, then we can see here the base 64 encoded value. And this is the same value as we have in our Key Vault. I just said that we have to recreate our pod so it resyncs the secrets because we don't have any auto rotation configured. So now let's do this in the last step of this demo. The first step is to update the configuration of our add-on. So we use the AKS add-on update command. Then we provide the name of our extension, the name of the Kubernetes cluster, the resource group, and then the last two parameters enable the secret rotation. This means that the secrets are also updated when the pod is already running. Then the rotation poll interval configures the time between the polling. With 10 seconds, this means that the pod checks every 10 seconds if there is a change in the secrets. By default, it's 2 minutes, but for this demo, I don't want to wait 2 minutes, so I set it to 10 seconds. Updating this extension will take again between 5 and 10 minutes. Once the update is finished, we will update the Key Vault secret, and then we should see it automatically updated in our pod. So let's stop here and then we continue once the add-on has been updated. The extension has been updated and now checks every 10 seconds if there's an update in the secret in the Key Vault. So let's update our Key Vault secret. We use the AC Key Vault secret set command. Then we provide the name of the Key Vault, the name of the secret, and then a new value. The value, this is an updated secret, should also appear in our pod within 10 seconds. So update this. Now we're going to wait a couple seconds and then we check again the volume of our pod. And this should now reflect the updated secret. So let's clean up this terminal. And with the kubectl exec, then the name of the pod, and then we use again the cat command and the path to our secret. If we check this, now you can see here, this is an updated secret. So we have updated the secret in our volume without changing anything in our pod configuration and even without restarting it. The same with our Kubernetes secret. So if we get our secret, then we can see here that this value also has changed. I forgot to take a screenshot, but I think this part here is different than the one we had before. And also the value is way longer. That's everything I want to show you today. One thing I want to mention is if you have a programming language that doesn't read secrets on the fly, for example, with .NET, environment variables are only read when the .NET process starts. This means when the application starts. So even if you update a secret, your .NET application will still read the old secret. This means you have to restart the pod. There's an open source software called Reloader, which automatically and gracefully restarts your pods. And with this, you can achieve updating the secrets with the Key Vault extension and then automatically restarting your pods. And when the pods restart, they will also read the new secrets. This means the operator doesn't have to do anything except someone has to update the secrets in the Key Vault. This is the end of the demo, but there's one more screenshot I want to show you to recap what we did today and how this whole synchronization process works. To recap, today we created a Kubernetes cluster, then a Key Vault, and then we installed the Azure Key Vault Secrets Provider extension on the Kubernetes cluster. After we started a pod, we had this workflow. So the Kubernetes API server wanted to create a new pod and told the kubelet that it should schedule a new pod on its worker node. Then the kubelet checks the secret store CSI provider, and this provider creates a temporary volume and attaches it to the pod. and at the same time it requests the secret from the secret store CSI provider, and this CSI provider is our extension. This means our extension fetches the secrets from the Azure Key Vault. And this fetching is done via gRPC, but we didn't have to configure anything except the identity. And the identity had the permission to read the secrets, and therefore we could get the secrets. Once the secrets or also the keys or the certificates have been fetched, they are returned to the secret store driver, and then the driver writes them to the volume. Additionally, the driver can also add them as an environment variable or as a Kubernetes secret. Thank you if you made it till the end of the video. If you have any questions or comments, let me know in the comments down below. If the video was useful to you, please like it and share it. And if you're interested in more Azure, Kubernetes and security topics, I publish new videos every week. So feel free to subscribe and get updated once I publish the video. Thank you for watching and see you next week.